Chapter 1, Lesson 8 of Geometry. We're going to look at the coordinate plane and how to determine lengths on a or distance on a coordinate plane. And then we'll look at a midpoint, how to determine the coordinates of a midpoint that's on a coordinate plane as well. So we're going to look at coordinate planes first. So there's some information that maybe some of it's you're familiar with and other ones you're not. So we'll go through it all. It says here you can think of a point as a dot. We talked about that as a definition of a point as we represent it by using a dot. And remember that a line is just a series of these dots or a series of these points. So in coordinate geometry we describe a point by an ordered pair x, y. So when we go to put a point on a coordinate grid like we have here, the coordinate of that point is given an ordered pair where you have an x value, which always comes first, and a y value, which always comes second. That's why it's called ordered, because the order is always the same. Now, we call these x and y values the coordinate of the point. So here you'll notice we have point T, and point T has the coordinate 5, 2. So what does that 5, 2 mean? Well, the 5 represents how far you go from the origin along the x-axis. So we would go 5 to the right because going to the right is positive. We would then go up 2 because the second value is the y value, or the up and down value, and it's positive, so we would go up 2. So the coordinate of this point is 5, 2. And any point that we put on the coordinate grid has this ordered pair as its coordinate. And if we take a look at point R here, if we begin from the origin, everything begins from the origin, which by the way has a xy value of 0, 0, meaning you do not move horizontally and you do not move vertically, and that would put you at a location called the origin. Now to arrive at the location R, because remember a point is just a location, its coordinate tells us how to arrive at that location. So always from the origin we would go 4 to the left, that's what -4 means, and then 1 down, that gives me or helps me arrive at point R. So these coordinates are just locations on the coordinate grid of a point or a location. There's some other information here that'd be nice to know. We won't spend a lot of time worrying about it, at least right now. We begin in this quadrant right here, this quadrant 1, and then we number them counterclockwise. So this would be quadrant 2, quadrant 3, quadrant 4. And these plus or minus values are the values of the x and the y's in that quadrant. Meaning if you have a point located in quadrant 1, the x value is going to be positive and the y value will be positive as well. If you have a point located in quadrant 2, the x value is negative because you'll have to go left to get there, and then the y value is positive because then you'll have to go up. Quadrant 3, both are negative, left and down, and quadrant 4, the x is positive, moving to the right, but the y is negative, going down. Now, we can use the ruler postulate. We've used the ruler postulate to find the distance between 2 points, or the lengths of a segment. You remember we use the absolute value of the coordinates of the endpoints. And you can do that as long as those points are on a horizontal line or a vertical line. But if a point doesn't lie on a horizontal or vertical line, you cannot use the ruler postulate because the distance is a diagonal distance. And there's no numbers along that line or coordinates along that line. Those points on the line now have 2 parts to its coordinate, an x and a y. So in order to find the distance between 2 points that are not on a horizontal or vertical line, we're going to have to use what we call the distance formula. Now this is what the distance formula is, and you're going to need to memorize this, so write it down and make sure you work on memorizing it. The distance of between 2 points, that's what this little d represents, is the square root of, and then in parentheses you subtract the x coordinates of the 2 points and square it. So this number will always be positive because you're going to square it. Plus, then you take the difference of the y coordinates and square it. So this number will always be positive as well. So you should never, no, you shouldn't, you will never get a negative value underneath here. If you ever get a negative value underneath here, you should stop and know and recognize that you've done something wrong. And most students will arrive at a negative number under here when they use their calculator to enter in this, because they won't enter the negative value squared correctly in the calculator. So just know this, that this number will always be positive and this number will always be positive. So the value when you add them should always be positive as well. So what you do is you notice that here we have a point in the coordinate grid here, and here we have a point in the coordinate grid, and notice it's not on a horizontal or vertical line, it's on a diagonal line. So if I wanted to find the length of this segment, I would take the x-coordinate of this point, which I have here, minus the x-coordinate of the other endpoint, and subtract them and then square it, giving me a positive value, plus then I take the y-coordinate of this point, subtracting the y-coordinate of this point, and then square it, thus giving me a positive value. Now the order of these doesn't matter, and the order of the x's doesn't matter, because you're going to square it, it's always going to be positive anyway, so that order doesn't matter. And how you do this doesn't matter, but as a matter of convention, we have the x-coordinates first and the y-coordinates second. Okay, now this formula comes from a version of the Pythagorean theorem, and if you're familiar with that, I've heard it before, that's great. If not, we're going to use it a lot later on this year, but this is the formula. So let me go ahead and do an example of how to find the distance between 2 points, and then we'll wrap up this video. So here's a segment that has one point E, which is at 6, -2, and another point F that is at -2, 4. So just quickly to kind of get a mental picture of where these points are, if we went over 6 and down 2, so this would be 6, -2, and that's point E. And if we went F, -2, and then up 4, so this point's at -2, 4, and that's point F. So if we drew a segment, and I want to know what's the length of that segment. So because it's not a horizontal or vertical line, I'm going to use the distance formula. So we're going to do the square root, distance is, I take the x-coordinate of this one, which is -2, minus the x-coordinate of this one, 6, and then I'm going to square it. Plus, then I'm going to take the y-coordinate of this, 4, minus the y-coordinate of this, and then I'm going to square that. So then I just go ahead and simplify this. So -2 minus 6 is -8, and then 4, 2 negatives plus, make a positive, so that's going to be 4 plus 2, so that's going to be 6 squared. Now again, this is a negative number, but when you multiply a negative by a negative, it's going to be positive, and I said this is always going to be positive, so keep that in mind. So I square 8 and that, and I get this, 64. I add those two together, the square root of 100, and the square root of 100 is 10. So the distance, or the length of EF, is 10. So that's how you use the distance formula. It's simply taking the x values of the two endpoints, and then the y values of the two endpoints, and substituting them into the distance formula.